Introducing the Rational Developer for System Z Integrated Debugger. Rational Developer for System Z, RDZ, and the Debug perspective are built on the Eclipse framework, which enables the display of multiple views, tabs, and perspectives. This is an example of the Debug perspective that will be covered in this demo. This is the default out-of-the-box debug perspective that you can customize according to your preferences. Notice that we have two perspectives open, the Debug perspective that we're in now, and the Remote System Explorer, which displays your host network and files. A perspective is made up of a group of views, and if you select different tabs, you'll see different views. You can choose to run JCL in the background or within the Debug perspective. To submit a JCL job, begin in the Remote System Explorer perspective. Double-click on the file to open it in the editor, then type sub in the command line. When you submit a JCL job, you will be prompted to open the Debug perspective. And the Debug perspective opens. Another option is to right-click on a JCL file in the Remote System Explorer view and select Submit. One of the key features of this debugger is that you have full access to the feature-rich, language-sensitive COBOL editor integrated with RDZ. Notice the bug icon that indicates you are in Debug. The Debug view in the upper left shows the host information. Normally, a program just runs from beginning to end, but the Debug view enables you to see exactly what it's doing by stepping through a line at a time. Step over will execute the statement and go on to the next one. You can single step through a program or add a breakpoint so that it runs and stops at a certain location. Double-click in the column to add or remove a breakpoint. At the breakpoint, you can step into the program call for more details or select Step Over to execute the code and move on to the next statement. Notice the multicolor highlighting, which is a result of integrating with the RDZ editor that supports COBOL syntax. It makes it much easier to quickly scan and navigate your code. Another great feature is that the information about COBOL is being parsed as part of RDZ, so if you select a variable, you can open the declaration and go directly to the source. Because it's so closely integrated with RDZ, the debugger offers far more features than your typical debugger. Right-click on the variable to open the declaration. The arrow points to the line that you're about to execute, so even if you move your cursor all around to check variables, add breakpoints, etc., you can always see the line that's about to execute next. Notice the value of int initially contains nothing, but once you step over and move farther down in the program, int contains the number 00012. Another feature is that you can right-click on a variable and select Show all the occurrences of that variable in your program. The results are displayed in the search view at the bottom, and you can see all the places that variable was used. Select any variable and it immediately locates the code and opens it up in the editor for you to view. Tied in closely with the editor is the Outline view. The Outline view is ideal for navigating a program. You don't have to use Find to locate key parts of the program. You can just use the Outline view to navigate. Integration with RDZ also enables the debugger to use the Program Control Flow view to navigate your COBOL source. The Variables view shows information about the variables that are relative to the line in the program that you are currently on. You can filter the variables and choose to show everything or just variables within the relationship to the current line. By default, the variables are displayed in their natural form, but you can change the variable format at any time. For example, You could change the variable to display the hexadecimal format to see a hex representation of the contents of the variable. You can also view much more complex variable types. For example, the employee name variable has multiple values. When you open the declaration for employee name, you'll see it is made up of two parts, first name and last name. And the first few elements are conveniently displayed without having to expand it. If there are variables that you are interested in watching all the time, you can right-click on them and select Monitor Local Variable. And they will be moved to the Monitors view. These variable monitors will now be part of the program all of the time until you modify it. In fact, even if you stop and restart the program, they will remain in place. At first, the variables are not allocated. You need to step to the breakpoint in the program. Notice the variables contain values now. The values and breakpoints are remembered. The Monitors views shows any places in the source where monitor expression has been selected. It allows you to monitor particular values at every point a break occurs. It will also allow users to change the values at those points. You can choose one of your complex variables and select Monitor a node in the Monitors view. If you're in the Variables view and you want to monitor something, simply right-mouse-click and select Monitor Local Variable and it will move into the Monitors view. Toggle this icon on and off to show declared type names. The Breakpoints view shows you where all the program breakpoints are. Breakpoints are places in the program that you want to stop. Just double-click to add a breakpoint. Every breakpoint that you add in the Editor view also appears in the Breakpoints view. If you double-click on a line breakpoint is automatically added. Then you can edit them by right-clicking and opening the menu. Notice these are all line breakpoints. In the Breakpoints view, you can add all different types of breakpoints. An address breakpoint is an instruction address that you want to stop on. An entry breakpoint is a particular entry you want to stop on, for example, another program or a subroutine. Line is just another way of adding a line breakpoint, although normally you would add them in the editor. A load breakpoint allows you to stop whenever a module is loaded, for example, dynamically linked libraries. An asterisk will cause it to stop on anything that's loaded, or you could type ABC and it will stop at any program that begins with ABC. The integrated debugger also allows you to enter a label or description that persists across the debug sessions so that the user can annotate meaning to a particular breakpoint. For example, a note to indicate that this is where an error occurs. Monitor memory is another key feature of the new debugger. Right-click to select it. Monitor memory allows you to show the memory in different formats called renderings. This display is in raw hex. Next, we're going to demonstrate code coverage. When you run code coverage, it is just like debugging, except you add a switch that tells the program to run code coverage. We'll comment out this call to show you how it works. Then add CC for code coverage to the JCL file and submit the job. Code coverage uses debugging technology to track all the executable lines in a program and show you which ones were hit and which ones were not. Notice in this case, 83% of the executable lines were covered, so out of a total of 43 lines, only 36 were actually hit. You can expand the contents for more details. In this case, none of the lines in init table were executed. After opening it in the editor, you can see that this call was commented out. If you return to the previous command, you can double-click to open that section of the program and scroll down to see where the call didn't execute. Notice the lines are all green on the left until the program reaches the call that didn't execute. The line turns to red to indicate that it did not execute. If we go back to the program and remove the comment from the call, save it and resubmit the JCL, that will rebuild the program so that we can rerun it in code coverage. This time we have 100% success. The History view lets you track and compare the changes in each of your sessions. Another option is to modify the code coverage results, for example by capturing just function level versus line level. When we modify it and resubmit the job, this time the results only show the functions. If you remove CC, it will run in debug mode. If you leave CC in it, it will run code coverage. This concludes the demo. Please click on the following links for more information and demos.